Power stations like this are awesome. They're also really, really expensive. So in this video, I'm going to show you how you can make one on your own, which will be cheaper and also serviceable if anything goes wrong. These things are also really heavy. Ugh. Ugh. Okay. Now, portable power stations like this go by a lot of names. I've heard them called generators, solar generators, big old batteries, you name it. But basically what these things are, it's a big lithium battery that can put out 12 volts or regular wall current and can usually charge off wall current or solar. It's all packaged into one box, and like I said, they can be very expensive. This unit is right around $2,000. What I'm going to show you over here is how you can do it with components, making your own. And what this means you can do is you can pick how much capacity you need, how much output you need. You can build exactly what you need and nothing you don't, which means you can build it a lot cheaper than one of these. What that also means is if a component goes bad, you'll be able to go in and fix it instead of just having to go out and buy a new one or cross your fingers and hope they'll honor the warranty. Now, if you like this kind of content, DIY videos that'll save you some money around the house, please consider hitting that subscribe button down below. It doesn't cost you a penny and it really would help us out and we would really appreciate it. And it'll let you know when we're coming out with new stuff. So let me show you what you're gonna need to do this project. So here's the basic componentry that is inside every power station that you see. First and foremost, you've got a battery. This is where you're storing your juice. Now, this is a lithium iron phosphate battery. You could also use a regular lead acid deep cycle car battery for this project. Whatever you got lying around the garage, if you've got something perfect. This happens to be a battery from Time USB. It's a lithium iron phosphate battery, and lithium iron phosphate is better than a lot of the other lithium batteries because they're less prone to doing stuff like blowing up. So you've got storage for juice. Now you need to get the juice into whatever you're trying to power. And most likely you're going to be powering things that run off wall current. So you're going to need a power inverter. This is DC juice coming out, 12 volt, and this is regular wall current that comes out of this. You have regular wall type plugs on the back of this guy. So that gets your current from 12 volts so you can power your normal plug-in home appliances with it, charge stuff and whatnot. You also have to charge this thing, and there's two primary ways that these things charge. One is solar. I've got a small solar panel here for the purpose of this, but I've got a lot more. This is just one I had laying around the garage, and I've got a solar charge controller. The one thing you do need to do is you got to make sure your charge controller is set up for the kind of battery you have. So if you're using a lithium battery, you want to make sure your charge controller will work with a lithium battery. If you're using a lead acid battery, a typical charge controller can work. Some of them can actually do both, so you can kind of shop around. I will have links for this stuff all down below, and I'll have some options in there. If you're not charging off solar, you're going to want to charge off wall current. This is the battery charger for this guy. This just plugs into your wall, and you're going to need some wiring. And then depending on what kind of battery you have, you're going to need a way to monitor the battery. Now that trick that I said that this battery has is this battery actually has USB, so you can actually connect to it from your phone and see what's going on. A lithium battery has an interesting discharge cycle. If you're familiar with regular 12 volt lead acid batteries, they kind of gradually discharge. Lithium, they have a very flat curve and then they drop off at the end. So you need to run something like this. This is a shunt. And what this does is this connects to a little, basically a computer that tells you how much juice is coming in and going out of your battery so you can monitor exactly what you have. I'm going to be hooking this one up so I have a monitor on my battery box, but this one actually has a way to control it or get into it via Bluetooth so you can see exactly what's going on. In addition to this component, you're going to need some wires, some connectors, and some other bits that I'm going to show you along the way, and you're going to need a box to put it all in. If you're as old as I am, you remember the clear computer craze from the late 90s, early 2000s, so we're going to go clear again and just put it in a clear tote. Now you can put this in anything. You can put it in a tote, in a toolbox, in a crate, or you can mount this underneath a compartment in your truck or RV and forgo the crate altogether. But we're going to put it in this. It'll give me a little extra room to shove extension cords in there because this thing's going to live primarily in my truck. So the first thing we're going to start doing is laying out all of the components, and I'm going to be using this thing. It's a plastic cutting board, and these are great for this kind of stuff because you can get these very cheap. You can screw into them, they're not conductive, and you don't have to worry about all the stuff that you would have to worry about with wood. So what we can do here is take this thing and mount all of our components to it. So let's go over to the bench and start mounting everything up. So we've mocked up all our components, and it should actually just barely fit on this cutting board, still giving me enough room to get all my plugs in and out where I need to get my plugs in and out. So we're going to start by mounting the solar controller and getting everything in kind of mounted around it. So we'll slowly move stuff out of the way. And what I'm going to be using are these little self-tapping sheet metal screws to go on in there. Then from there, we'll get our inverter in here. Actually, I can slide this guy down a little bit. Now, let's mount our charger. Now our charger, we're kind of having to straddle things a little bit to get the charger in place, but it's gonna work. So now we got all our electrical components in place, but now we have to figure out how we're going to wire everything up. And that's gonna be all run through these bus bars. That way we can hook all the positives to one thing, all the negatives to one thing, and connect it all out from there. We're gonna do the positive bar first, using those same self-tapping screws. And our negative bar, I'm gonna put over here kind of in the middle of this whole setup. And now we have our board laid out. Now we've got to hook up all of the different electrical connections. So let's get cranking on that. And if you haven't done electrical work like this before, it's actually less scary than it looks, even though we're dealing with kind of big wires. Think of it just like a plumbing project. You have current that's got to flow in one direction. So we're going to have this bus bar here connected to the positive terminal on our battery. This is going to be connected to the negative terminal on our battery. Everything else is going to connect to here. So our inverter here, we're going to wire that up to the negative and the positive. Our solar controller here, same thing. We have the outputs for the battery. So we're going to hook that up to the negative and positive. And then the charger itself in this situation has its own separate charging cable. It's going to be running to the battery. If you're not running a charging cable like this and you're just running something with prongs, you can also run them straight to here as well. Now for all the wiring here, we're going to be using 8-gauge wire. I would recommend going with 8-gauge, but you want to check and see with all your components what they recommend so you get the right wire. You want to get a thick enough wire. Too thin of a wire, you're going to wind up with overheating problems, melting wires, and all sorts of awful things. So I've got some 8-gauge wire, and then I've got a whole pack of connectors here. And then my favorite crimping tool, and you can use different crimping tools, but I like this one. You kind of put the wire in there, smash it with a hammer. We'll show you how that works right now. Let's start cutting some wires. And we're going to start with wiring up our inverter. So we went through our box, we found the correct size terminals here for contact there. So we're going to crimp this on. Let's go over and I'll show you how this crimping tool works. We'll start by clearing a little bit of the insulation off the end of this thing. And we'll just start with our negative side first. So we've got our insulation cleared off. Twist that guy up. Take some shrink wrap. This is shrink wrap that comes with that wiring kit, and I will have a link to the wiring, the shrink wrap, and all that good stuff in there. So we're going to put the shrink wrap right over the end of our wire, and it's time to crimp. And like I said, the crimping process is pretty simple with this one. You lift up, place your crimp connector in there. So I'll turn around here so you can see what I'm doing. Got the crimp connector in there. Now we're going to take the wire and feed it on into the end of the crimp connector. And then once it's in place, you just take a hammer, give it a couple good smacks, and you've got a good connection. Then we can take our shrink wrap, push it up over the end, grab a lighter, so we've now got our negative end hooked to the negative side of our inverter. We're going to run the wire up and trim it to length so we can connect it to the negative side of our bus bar. So we're just repeating the exact same process on the other end of the wire. Now off camera, I did wire up the other end of the inverter because I didn't want to have to put you through watching me just make a bunch of wires. But we have the negative end going to the negative block, the positive end going to the positive block. Now we're going to hook up our solar charge controller. So we have another wire. We made another wire here coming off the positive, and that's going to come around here. The thing is with this one, on the other end, we are not crimping a connector on there because these thread straight into the back of the charge controller. You'll see here, this is where the solar panels hook in. This is where the battery hooks in. So the same deal, red positive goes to red positive and negative. I'll show you how those go in right now. So I'm going to start with this little short, stubby negative wire that I have here. We're going to twist the ends up, and then right in the bottom here, there's a negative. We're going to go right in the negative side for the battery, and then take a screwdriver and tighten the wire in place. These things usually come from the factory with these screws backed all the way out. If they're not, you may have to back them out on your own. We'll do the exact same thing now with the positive side. Solar controller hooked up, our inverter hooked up. The battery charger, there's two ways to do the battery charger. You can either hook the battery charger straight into these bus bars, or you can go the other route and hook the battery charger straight to the battery, depending on what kind of battery you have. Now, this charger actually comes with a connector and another end here, so I could shorten these wires. I may in the future, just for aesthetic's sake. I could just unscrew these and shorten these, but for now, we're just going to hook them up as is. So same deal applies here. We're going to go negative to this bus bar and then positive to this. And now we've got the charger hooked up. And there's really only one thing left to do on this board, and that is to get the leads coming off of the solar controller so we can charge the sucker with the sun. And for the solar side of things, you're just going to have to make the determination based on the panels that you have. Now, the panels that I have all seem to have XT90 connectors or wires that adapt to these, and I have this pigtail laying around. So I'm going to use this pigtail in there, and that way I can adapt out to all the different panels that I own. But you're going to have to use whatever kind of connector or wiring that adapts to the panels that you have. And then finally, before we button things completely up and start putting them in the case, I want to make sure that I have all of these connectors tightened down. And we do still have one more lug up here. We're going to be hooking the battery to that, and then we're going to be putting these on. But we got to get this whole thing in the box. Now let's turn our focus to the battery and getting the shunt hooked up so we can actually see how much juice is going in and out of this whole setup. In the case of the battery we're using, we don't actually have to use this, but we're going to use it anyway. What a shunt is, this little guy goes in line and it essentially measures, with the aid of this, how much juice is flowing to and from the battery. So it always knows how much the battery can hold, and therefore when juice is going in, it registers it, and then when it's coming out, it also registers it. So it knows the current coming in, current coming out, and that way it can tell you how full or empty your battery is. These are actually really cool little gizmos, and they're relatively cheap. So if you're doing a lithium battery, I would really recommend doing one of these. Or if you wind up using the battery that we're using, which is that one from Time USB, this is actually built into the battery and communicates to your phone via Bluetooth, so you don't have to do this and you can check it remotely from your phone. But for the purpose of this one, we're still going to hook up a shunt, even though technically it's probably not necessary. Now, I know I've said the word shunt and mentioned it a ton of times here, but let me show you what it actually does. And I've got my phone up because right now I've got my phone connected Bluetooth to the shunt that is in the Time USB battery here. So it's kind of unique about this battery, but I'm going to show you how both shunts are working. Now, when we pop into the app here, we can pop open the battery, and here you can see it tells me we're at 54% charge. It tells me the amp hours that are left in the battery. Right now I have 79.9 amp hours, 54% charge, just went up a little bit. And it says it's charging, and that's because I do have this thing plugged in. Down below, we can actually see the current that's coming in or coming out of the battery. So this basically gives you exactly what's on the screen with some of those store-bought, pre-built power stations. It'll show you how much juice is left in the battery, how much time you have remaining based on your current draw for the discharge, or how much time you have remaining to charge it. Now, we do have similar data on the one here on the front of the box. Let me show you that one. Now, there, of course, is pros and cons to having the screen on it versus having it on your phone. Now, in my case, I think what I'm going to do is put it in my trailer, this battery, or one of these batteries in my trailer so I can check it with my phone, but I'm also going to wire up a screen, because if we're out camping and it's connected to my phone and my wife or my daughter want to see what's going on with the battery, see how much juice we have, they can't. It's connected to my phone. So that way we can check it both ways. But really, you got to make the decision for you what makes the most sense with what you're building and how you're using it. And the shunt actually is not that difficult of a thing to wire up. We're going to start by wiring it to the negative terminal of our battery. So we've got all that out of the way, and now we've got our shunt wired to our negative terminal. Now we got to wire the shunt up itself. And conveniently, there's actually a wiring diagram right on the back of the shunt, so this shouldn't be too hard. Now, we're actually not going to use the top two terminals, because that is if your voltage dips below 8 volts. We're going to be just using the other ones here. So we're going to be coming off of the shunt with a blue and a yellow wire. And the blue wire, we're just going to follow the wiring diagram. So the blue wire connects to the first terminal here. Yellow wire is going to come into the second terminal here. And these ones just slip in through the back. You just push them in and they should grab. So we got our yellow, or our blue in, sorry. Our yellow is going to go in next. And our next two wires are going to be our negative, that's going to go to our negative battery terminal, and our positive, that'll go to that positive battery terminal. So let's get those hooked up now. So now we've got the negative hooked up to the negative post and the positive hooked to the positive post. And here you can see we've actually got a full reading. Now what I'm going to do when I'm going to crimp all this together is I'm actually going to crimp this wire into the terminals that go on those ends. But you can see right there, we've got all of our readings. Now we will actually have to set this up later once it's all hooked up, but at least we know now that it works. And I wanted to show you here what I was talking about. When I'm making the wire that's going to the positive post of my battery, I'm going to actually crimp the wire for the shunt into that, so that way I don't have to do a second terminal to the positive lead of the battery. So you can see here from my positive lead coming off the battery, I've got my wire, and I've got my positive right there for my shunt coming right out of that exact same crimp connector. I've got the battery more or less mocked up now. We've got everything hooked up for the shunt. I've got the positive power coming off there, and I made 2 leads that are going to hook back to the bus bars once we get this all installed inside the box. Now I am going to now remove that one because you don't want those 2 ends touching together. Things will get sparky, and with one of these it'll probably fry the BMS in there. So don't want to do that. So we're going to unhook that, put the safety cap back on it, and then get everything installed in the box. So now with the board that has all the power components figured out and the battery figured out with the shunt, we're now going to mount the thing inside the box. And we're going to do that using some recycled materials. This is actually the foam bit that the battery came packaged in. We're going to put that in there. We're going to glue it down with hot glue, put the battery on top of it, and then strap it down. So let's get that going. So what we've done is we've used a hot glue gun and we've glued this thing down into the bottom of the crate. Go me, I forgot to turn the camera on when I did it, and I can't shoot it again because it's stuck to the bottom of the crate. So now what we're going to do is we're going to flip this thing on its back, because we're going to be using this old strap that I had laying around the garage to actually tie this thing down. I'm curious to see actually if I can melt a hole in the bottom of this thing with my hot glue gun. It would mean I don't have to get out my Dremel. That's not melting. It's Dremel time. Now we can put our battery inside the box, inside our little tray there, so it'll be nice and snug as a bug in a battery rug. I'm not good at rhyming. Cut the strap down a length so we don't have a bunch of excess strap hanging. And now our battery is secured. Now we got to spin it around and install the board. And the beautiful thing with this, with the board in place, it's all in there, I can go in here with more self-tapping screws, which is what I'm going to do, put some screws to the back, and that'll hold the board to the back of the bin. Then we just have some final wiring to tuck in place, and we've got ourselves our power bank. So now we're just going to hook the battery to the board. And now with those hooked up, we can put these little caps on. This will prevent us from accidentally touching things that'll go sparky zappy. And I've got another one over here for this side. So now what we do is we hook our negative to our negative, put the cap on it, and then our positive over here with the red. And this will eventually hook into our shunt to the positive here. And now everything should light up. I can actually see that I've got juice running into this thing. And if we flip on our inverter here, our inverter light will turn on. This thing is powered up. And at this point, our power station works. We're just going to do a little bit of buttoning up to make it look a little bit better and make it function a little bit better. So the first thing we're going to do is we're going to cut a hole in the front of this thing to surface mount our shunt so we can see it from the outside. Then we're going to cut another hole over here because the power inverter that I have has something kind of cool that came with it. And that is this thing. It actually plugs into the inverter and it gives you plugs. So I can plug this into the inverter inside the case, cut an access hole in the front, and have this thing sticking right out the front so I can plug right to the outside. This thing's actually been sitting, the inverter's been sitting in my garage for at least 15 years. So I'm finally actually mounting this thing in something. So let's cut some holes. Take a wild guess who just broke his Dremel. So we're gonna stick the bit in a drill, and it's probably not gonna work. But I want to get this done tonight, so we're going for it. So I'm looking at my watch, it's 10:30. I started this project around 7:30, so 2 hours. It took me 2 hours to get this whole thing put together, powered up, and running. The problem is it's 10:30, it's dark out. So let's jump in the time machine to tomorrow when it's daylight so we can check the solar controller. Now, like I had mentioned at the beginning of the video, the battery I used is from Time USB, and it's got that cool feature where I can actually Bluetooth from my phone to it. I'll show you here on the screen kind of how that app works. But it means I can monitor everything coming in and everything going out of the battery. So I can check the battery state, I can check if it's charging or discharging, how much juice I've got left, and everything else, which is really nice. And it means I didn't necessarily have to do this little shunt on the front. Like I'd also mentioned, you can build this however you want. You can get the biggest battery you need or get a little bit smaller of a battery if you want to save a few dollars. And you can upgrade as you go. You can do the same thing with your charge controllers, your chargers, your inverters. You can build exactly what you want and not spend money on stuff you don't. So I will have links for all of this stuff and a lot of other options depending on what size of a power station you are trying to build. I'll have all those links down below if you want to check them out. But if this video helped you out, if it inspired you to do a little tinkering project in your garage, give it a great big thumbs up, hit that subscribe button. I know there was a lot in this video, so if you've got questions, please ask them down in the comment section. I'm happy to answer any of those questions. And of course, thanks for watching.